Okay, and then now I'm gonna pass it off to Sunny, and yeah.
Everybody see it okay? Okay.
Turn the lights out.
It's not content heavy, so that's the whole idea. So so today I will be talking about a career in the data science pivot from my own experience. So I'm gonna just quickly chat about my experience, and I'm gonna leave 15 minutes at the end for Q&A, so feel free to ask any question. Of course, my journey is nothing linear about it, so I hope that's a sense of encouragement as you explore what is the next step in your career, how you can map it to your ultimate, goal in your in your experience in the data science. So I'm currently a vice president for client development with a consulting company called Decision Point Analytics, and I oversee our North America landscape. And I graduated in 2020 from the Northwestern MSDS program. It's supposed to work. Okay. Yeah, I think we have some screen sharing on the. So you probably can see with some minor I don't know, privacy block or whatever, but this is kind of my journey. So I started my first role ever is actually lived in Japan for 2 years. I was there for 2 years teaching elementary school students English. So imagine you have first grader all the way to sixth grader. The first grader, they are literally learning how to write their name and saying their own language. To the sixth grader, they're about to go to college. They're like, where to put this? Why are we doing this? So I think from that, it's probably my first experience in terms of engaging with your stakeholders, right? The little kids in this instance, to say what type of information that they wanted to engage with you, and how can you keep them involved throughout your teaching career, and give me a sense of appreciation. We are all students, right? We are very early memory, and then to realize it's a very much of a thankless role. A lot of people do, they invest so much time in the content and not necessarily getting the sense of appreciation. So that was the first time, and that kicked off my career right after college. So from there, I got my role as a finance coordinator with Constellation Brands. It's located, actually, the headquarters located right in Chicago, a couple of blocks from here. So Constellation Brands is home of Corona, Modelo, Pacifico. You guys are familiar with some of those brands. And the fun fact, I found that role in Craigslist. So back in 2007, it was okay to post a job on Craigslist, totally legit, and actually get a job from Craigslist. So I thought that was quite interesting. But my journey really accelerated from 2007 to 2020. At that point, I was 13 years in that role. I moved from a coordinator to a manager, to an analyst, to a manager, to a director, and elevated in a way of, okay, what does that mean as a people leader, as a project leader, as a product leader? And that ultimately actually propelled me to consider a degree, because at the time I was leading a promotion optimization project. So we're working with outside data scientists, right? PhD, they're super smart and coming in to creating this model to help the business to say, if these promotions to the retailers, to the consumer, actually have been really effective, can you simulate in the future to say, is that the right place? the right time, the right depth to run that promotion again. Very simple concept, right? So they did a lot of different models, and the first reaction from the business was, why do we need to trust this model out there? And I started noticing a huge breakdown because the data scientist, super smart, explaining what the model is, and then you can just see people just rolling their eyes like, oh my gosh, you're losing me. And then there's that breakdown of that translation, right? What does it really mean for the business? Will ultimately have to make a decision from the model that you created to say, I trust it, and I'm gonna trust it enough to make a decision into the unknown, into the future, based on the work that you're delivering. So I realized that's a very important skill set, and I didn't have it. But I was trying to understand it from the individual who's implementing the work, and that's where I started exploring the right program for that, and ultimately attended Northwestern around 2017, actually, at that time, 3 years before I left the company. So I graduated in 2.5 years. It was really intense, especially for someone who has never done coding before. So everybody probably had that first experience, never done something to learn the language from a brand new experience. And I think I had a lot of fear and anxiety in the very beginning, but I always, challenge people and encourage people, it's just the right mindset walking into a different experience, and same for going into the data science career. So fast forward, I left that role after I graduated and quickly pivoted into a data science leadership role because the appreciation the organization at the time had for my business understanding and the technical understanding. And they do not want me to write the code. They said, the translation is so important of a skill set, and oftentimes it's hard to find individuals like that in the real world. From there, I was there for roughly about 2 years, and I went to Diageo and overseeing the data and data analytics strategy over North America. Diageo, again, is a spirits buyer, so they have Guinness, Johnny Walker. Those are some of their profile. Then fast forward in 2023, I realized there's so much more that an individual can do, and I think a lot of you guys can feel that way once you go into the data science arena to say, I can do so much more, right? How can I look for problems to solve and helping different varieties of the challenges in the real business? So that's what moved me fast forward to my current consulting role. So first thing I wanted to talk about is career pivot, right? A lot of people that I talk to as they graduating from the data science program, they usually have been doing something else. Could be doing marketing, they could be doing finance, something doesn't seem at all related to data science. And they always ask me, how do I pivot? And I say to them first is really have that right mindset and making sure you have that conversation with the closest people in your life, whether it's your husband, boyfriend, your parents, and make that pitch so that it is so convincing that they understand that you are ready for that pivot. Because if those people can't truly believe that you are ready, how do you sell that to the world, right? So mindset is very important to say, I have what it takes, and my experience is unique, and there is a place for me in the job, in the workspace. And then the second is tame your own voice. When I first started, it's very easy to have that self-critics, right? Acting up to say, you can't do that, right? Oh, this is too hard, or your experience is so not relevant in the past. Why would somebody give you a role as a data scientist? And I realizing a lot of time it's just your inner critics. So when you are able to manage and realizing that your biggest enemy is oftentimes yourself, and overcome that voice, it becomes so much easier as you're navigating this new experience, and then saying, what is your experience in the past truly make you unique as a data scientist than another person who actually did not have that experience. And also remember, there's no good or bad decision. a lot of time going into this career pivot in our life, we feel like, well, what if I take this role versus the other role? I feel like sometimes we feel like there is a consequence or a good or bad to that decision. But when you realize there's no good or bad at the end of that decision, there's no consequences per se, it's really just experience. It's really give you a sense of freedom when you think about making that decision for your career. And failure is good. And once you're able to embrace that and remember the decision is always temporary. I hear that often when people reach out to me and say, well, what if this is not the job I want to do? It's okay, then that means you need to move on, right? So giving yourself that sense of grace and freedom, I think it really helps going through that journey of pivot. Fear is a reaction, courage is a decision. I really like that quote because a lot of times it's constant battle is really within yourself, not against the outside world or the people who see your potential in your future career. And overcome your own bias. So during interview, I oftentimes I coach folks before they go into the interview to say, be prepared. A hiring manager will ask you the question, have you done X, Y, Z? And then your first reaction is, have I physically done that precise problem before? Your first reaction often is, no, I haven't. But I usually wanted to stop person to think through that path to say, rethink the statement, I have never done it before, right? To really channel, I haven't done it before in that way, but I have done something similar, right? Or if I've never done it before, but in school, I was facing that same challenge, I don't know, this is how I get there, right? And allowing someone to see your thought process, the way you approach a problem, your ability to show your curiosity and resilience, that's something cannot be easily taught. And that's a really good positive skill set to start practicing before you go into the interview. And then stop being bogged down in this to be liked. So we all want to be liked, want to be accepted, but it's okay to kind of remove from that because you can't be what other people want you to be. So to be very authentic to what you bring to the table, what's unique about you, and highlighting that. Confidence versus arrogance. I have a lot of young women in their career path that they oftentimes will ask me, how can I be confident? Or when I'm super confident, I feel very uncomfortable. Or am I arrogant in that situation because I say X, Y, Z? And I think the difference between confidence and arrogance is self-awareness. If somebody say, I feel very arrogant in that situation. No, that means you're confident because you're aware. People who are really acting out of arrogance, they're actually not aware that they are doing that. So confidence is something that you had to go through to train that, right? To go through a situation, to go through experience. But like that first point I said, if you cannot convince yourself or the closest people to you that you're ready to make that move, it's difficult for you to sell that to the outside world. Practical steps. Now, before you start even your first course, second course, that's something I've learned is really start, articulate yourself, especially with your past, right? Like I said, if somebody have a finance background, marketing background, HR background, but think about analytics, it can be in all of these areas. So lean into what you have done in the past and think about the skill set, technical skill set you have acquired to solving these problems with your domain expertise. Now you're becoming more competitive than someone else just have that knowledge. Second is creating digital footprint and take certification, right? Language, especially Python, R, data science, if you don't use it often, you do lose it. So keep up with what are some of the most up-to-date kind of activities, whether it's cloud database, that's something interesting to you, understanding generative AI. There's a lot of courses you can learn how to build your own little chatbot. Those things, as you go through that experience, you can showcase for it and make sure you have that digital footprint early on. So that's something I learned, unfortunately, more toward the tail end when I was about to graduate. And somebody asked me, hey, have you ever done your, GitHub? Like, oh, shoot, never done that, never thought I need to put my work out in the public. So start doing that early often, right? So that's also your digital resume that is available for the world to see. Also attend relevant events, right? We were just talking about early before the session is Women in Data Science or Analytics Unite. I don't know if you guys have heard about it. It's a lot of analytical folks in the industry coming together, sharing their best practices and leaders talks and so on and so forth. Databricks, tons of free actually getting together. They bring, folks doing sports analytics into the mix and all of that. So there's a lot of good event that is available, especially in Chicago. So look up a few. And once you do that, the second thing I wanted to challenge you is to make it consistent. Because building that network and relationship with people is not one shot, right? Going to these events that you find so much value and do it year over year, right? To make it a habit to be there. And again, going back to have your story, have your elevator pitch, 30 seconds, practice it. The more often you do it, the more, perfect it will be when that right role, right hiring manager is talking to you over the phone. Take charge. A lot of time it's kind of wondering, am I ready? Am I not ready? Make sure you start taking the first step. You have to start somewhere, right? Whether it's looking within your network to say, who are these individuals that I admire from afar, reaching out to these people, that's your first connecting your LinkedIn. Because if you don't, your chance is 0%. If you do, you already 50-50, right? In a probability of success. And the power of network community is so fundamental for us of human. I was reading a book recently. It's called The Geek Way. Has anybody heard of that book? The Geek Way? Okay. I do really like it. It talks a lot about the difference between human versus all other, mammals. So the interesting study that they have done is they creating this environment. There's food, there is sticks that for people to create, to potentially create fire and all of these things, and they will put, mammals into that, like apes, in that situation. And then they will put a lot of babies into the other space. After a while, the group with apes, they're able to figure out that survival. They're able to make something out of the things that it was given to them in the environment. But human couldn't, because the most important thing in the human society is that teaching and learning. So you can give a human baby a bunch of sticks. They don't know how to make fire because that hasn't been taught. So the whole survival of humans is around community, is around networking. That's where we thrive. That's just literally in our DNA. So remember that that's where you will find inspiration. There is where that conversation will strike. That person could potentially be your next hiring manager. That they will connect you with someone who knows a job is open. So the power in network is absolutely your asset. If you start doing that now, do that, as a part of, almost like you're part of your day job. Board of directors. As you go through a certain point, and that's something I started, I sharing a panel before, is I started finding people who would challenge me and very diverse in their thinking to be my board of directors. So I will write up a formal offer letter to these 3 individuals. I ask them to sign it. I have a contract to say, what does that mean for being my board of directors? That putting my kind of future as a commodity, right? Putting my brand as a company. So that's kind of the concept a lot of people created, is to find these people who hold you accountable and investing their time in you because they believe in you. Mentorship, allyship, those are pretty common, but I have gone through probably the last 10 years, have two people, of all the people that I know, have two people that I can tell them I want to go to moon. They said, they will say to me, yes, you can. Do you have people like that? Oh, other than your parents. Do you have people like that in your life? And that's extremely empowering, because as you're going through that journey, pivoting, searching for that role, you have ups and you have downs. You need these people to come to you to say, you can do it. That's your feet up, dust yourself off, stand up, do it again tomorrow. So, I hope you can see this, but this is basically a very simple diagram of having the business on one side, technical on the other side, and this line representing my little search in this skill set diagram, right? At one point in my early profession on the left, I'm on the business, I understanding more about the business, building my acumen. And then I realized I need to understand more on the technical side, so I went straight to the technical side. Actually, at one point when I was pivoting, I was applying for data science role, like entry level, right? Type of role. Said maybe that I need to shift my career completely, just abandon what I have built in the business side. And I realized I wasn't happy. I don't think I can be just doing modeling and not really talking to the people, understanding what I'm trying to solve. So my happy place is somewhere in the middle. But that doesn't mean that's what your path is going to be. And if you find your path to say, I've learned the data science components, I'm doing the modeling, but I am that business leader, great. Find your dot on the left or in the middle. And if you are really technical and you wanted to be a lead data scientist, senior data scientist, great. But don't be apologetic about what you're doing, right? And then find that place that truly makes you happy. And that could be managing people, that could be managing models, right? I don't want to do managing humans, but find that happy place and going through that journey on your own. So that being said, that's everything that I wanted to share from my own career. I will leave it open for anyone who may have some questions, and love to answer any of theirs from out there.
You do in-person questions, and then we have some prepared virtual questions as well. You want to start with in-person?
I love your diagram, by the way, because traditionally, MBA programs, when I first started, were designed for people who are technically trained, but who didn't have the business skills. And it really was great because you can teach quantitative stuff, you can teach business skills and quantitative stuff to people who already have that background. And so we're trying to translate technical people into managers. But now we have a lot of people who are skilled as managers, but don't have the tech side. So we're going in two different directions, and that kind of in between on the Venn diagram could be a place to interface where you bring people who are coming from the tech side to do a degree in management or leadership or something on the kind of soft skills, and taking somebody from the soft skills and getting them some more technical skills. And it depends on which direction you're going. So if you're coming out of you were a computer science undergraduate, now you're a data scientist, but how I manage those things called people, then an MBA might be right for you. And if you're coming from the MBA side, where you were so allergic to math that we couldn't even show you anything with an equation, which is most of the MBA undergraduate business students, how do we bring them together? And then in that space, you might build a team of people whose strengths fill where you're lacking, and whose weaknesses you can work with. So I love that idea of this translation area But it's certainly easier if you start out with the hard sciences and the hard skills to learn the soft skills. And I'm sensing from looking at the room, that's where you're coming from. Is there anybody who's coming from a purely business background who's looking to get into the technical side of coding? So we, if I were to design programs, share with you how somebody is really good at modeling and making a good manager, that would be useful. So I love your diagrams. It makes a lot of sense.
Yeah, so, my experience is from obviously the business to the technical and then get to the middle. And in the business world, what I have observed is there are a lot of time technical people, they're so passionate about the models. They forget what is the business is trying to accomplish. And a sense of accomplishment and recognition become, wow, that's the most sophisticated, right? That's the mean, and your R square is perfect, pat on your back, your job is done. No, there's so much more to say, okay. And that's what I usually talk to my technical team is the data science component is 30% for the success of the project. That's 70%. You're dealing with people who are making decisions or not making decision with their model. And if they do make a decision with a model, what's the risk involved? And what's the value proposition that is involved? How can they do better by not having a model or be more efficient by having a model? So those are things you have to quantifying it. And that's not data science math. It's Excel math that you have to be able to articulate, because if you talk to the CEO, I learned early on, I remember I had this like 15, 20 slides put together and tried to talk about the importance of data science. The first 5 minutes, the person stopped me and said, okay, you told me in the first 4 minutes. What do you want from me? And that's what the leader's thinking. So when you wanted to get to that level to really create impact in what you're capable of doing, is to think that extra 70% outside of the data science to make sure you get the attention of people who has the influence and power to make a difference in the business that you are supporting.
So you have to answer one question. So what?
This-
That's what you have to say. So what does this all mean? And that's what I fear sometimes with students is they got a beautiful model, they got lots of data, and how does it help me move my business ahead? How to get me to sell more cereal or more toilet paper? And if you can't answer that, that's your elevator pitch. And this was the same argument we had with engineers in the old days. Engineers were like developing really cool products and they understood them, but how do you explain that to a housewife who's going to use it? What's the benefit? And it's the same with data. And that's why if you put together great data skills and technical skills with the ability to answer that question, so why is this important? Why am I here? You will get your model to the person buying it much faster. So come with MBA approach.
And then we had one question from online.
I'm happy to read it. That'd
Okay.
be helpful. Great.
Oh.
Okay.
Yeah,
So
so what is the math preparation you have before enrolling the MSDS program at SBF? So everybody will laugh. Back when I enrolled in 2017, there's none. I walked in cold turkey, and the first semester I took doing math in Python in another course. I can't even remember what it was. But apparently that 2 courses are considered full-time course. I wasn't aware of that. So I was going in, learning statistics, going back to your college days, and learning Python for the first time in that one course. I remember there are a couple of days in the first week I woke up like sweaty at night. So unfortunately at that time, there wasn't any prep, but now there is intro to Python, intro to R, So, but I would say if you don't remember what statistic courses was like in college, go back to review all of these because that's really fundamental, right? For the data science, it's just using the the Python R, these programming language to do it faster. So that's still the fundamental. So take a couple of refresher on the statistics. And if you can do intro to Python on your own, there's a lot of free courses online. Those will help you transition into a technical degree. Okay, well, thank you everybody for your time.
Great, thank you so much. Great, our next speaker is going to be Sherry. Whenever you're ready.
Hi, everybody. My name is Sherry. I'm a data scientist at Asperiton. I didn't graduate from Northwestern. I graduated from DePaul with a master in data science. I don't think I'm an expert in LLM or natural language processing, but LLM has been the thing that everybody is talking about, and all the companies are trying to use it to either improve their productivity or to create a product. My company too is trying to do that. But one of the things I'm always thinking is, what can I do as a person to use LLM to make my life better? So that's what this talk is about. It is not that I find a lot of answers, but it's a summary of some of my thoughts on how I think I can use it. And hopefully it'll be helpful for you too. But before I start, I want to ask a question. And again, I have a master in data science. I'm not traditionally trained engineer, but I just want to ask here, how do you think, how long you will need to create a web scraper to actually, I'll share this website I have here. To script this website, a very simple one. This is a conference that, actually the reason why I was thinking to do it is even like, this is a conference that we know we want to read the papers from, but there's so many of them. I want to have a list so that I can save it and look at it later on easily. How long do you think? Again, it's not that complex. There are links and there are authors. How long do you think you'll need to create a web scraper to really script this?
Or 2 hours.
1 or 2 hours. Okay,
10 minutes.
10 minutes.
Almost instantaneous. LLMs,
Hello?
almost instantaneous.
Yeah,
2 or 3 tries at the prompt.
yeah, I like that. Yeah. So I would say that if it's me, I'd say I'll give myself maybe a couple hours to even a day, just depends on how this website is created, right? And yes, it did only take a couple minutes. Now, I want to share that. So this is how I'm trying to do that now with LLM. I'm literally trying to copy the structure of the HTML because you can guess why I need that, but you'll see it soon. So it's really, really long. I don't need all that. So I kept just the top couple hundred lines, deleted all the later ones, and then go to LLM. I want to just pause there for a bit. This is really what it takes. I was asking it, hey, I want to script it. I need these different things. And then the reason why I copied that HTML is because I tried a couple of times. It can't read that URL. So then it needs to know the structure of the HTML. So then I just give it as an example. This is how the first couple few lines looks like. Can you do it for me? But also notice that I can do it in Python, which is a language that I'm really familiar with. But in the modern browser, you don't need to do that. If you know they have a console that you can actually write JavaScript and then you can run it without having to deal with installing Python, creating the different package, the environment and installing the packages. So really, whoops, I didn't want to skip the best part. We already saw that. So then literally I was reading that and I copied this code. I did read it. I think it looks fine, but I'm not a JavaScript expert. It just kind of makes sense. So I thought I'll just try it and pasted it. Then it downloaded the JSON file that I asked it to do. And then it has all the right information that I asked for it. And I compared it and I see that yes, it did not hallucinate. It was the right thing. So that's right. It only took a couple seconds with ARM. And another thing I wanted to do, right? So how long do you think it's gonna take to download all the images from any given Instagram account? Without ARM, let's say. Or let's do a little technical analysis, right? If I were gonna do it, this is actually Instagram. I follow this account. I have 2 little kids. So they have inspiring images that I would usually want. And the problem is you'll see that the website is dynamically loading. That's a technical challenge, right? Like if I want to download the pictures, I just need the URL, but how do I get that? I need to load it literally, and then I can get the images. So that's kind of the difficulty. And also, again, I don't want to do it in Python if I don't have to. If I can just do it in developer tool, I would prefer that. So how long do you think that's gonna take?
Why not? 7,000 scrolls.
Yes. If I were to give an estimation, I don't know. I feel it's impossible. Like, I don't think I'm technically good enough to even do that. But let's see. Of course, we're gonna do it with LRM, right? We all know the answer already. I'm gonna make it a little faster because this is kind of like a real one, and you'll see that there is a couple difficulties, challenges encountered. But the first thing, it just says use the developer tool, because I said, right, there is the challenge of dynamic loading. So then the first question was really seeing how I can use developer tools to deal with that problem. So it just says, okay, you can go look at the network tab of the developer tool. And then while you're loading manually, you're scrolling, you'll be able to find all the URLs loaded automatically in the network section. This is what I'm doing, right? If I filter the image right here, these are all the images, and something popped up as I was trying to record my screen. But the problem is, okay, I have all these loaded URLs. How do I download them as one go? I don't want to one by one load each one of them, download each one of them, right? So then I was asking that again. So it tells me, okay, there is this way to save it as HAV file, pretty much Internet Archive files. So all the ones that I loaded, I'm supposed to be able to save it and then again, remind you, I want to download all the images, right? So I got this code which tells me, okay, you just have to save the HAV file, and then notice that I didn't read the code very carefully. So what we ended up with is it printed out all the URLs. So it parsed the the Internet Archive files, and it got all the URL right. So at least we got that much. I realized that, okay, it's really just not saving anything. So here is when I start thinking, okay, so how can I download the images, right? So I started thinking I need more. So it gives me a little bit more of what I should do. But if you notice, it asked me to, and I just completely went to the wrong page. Already saw that. If you notice, it actually gives me a code that asks me to input my image URLs one by one manually which I do not want to do. Right, so I already noticed that, okay, this probably doesn't work. So now I'm really thinking, okay, how do I do that? I don't want to input my URLs one by one, and I already have some code. So one of the things that we always notice is when we deal with this chat interface, we keep on chatting with it, and at one point it's just gonna not remember what we're saying. So one of the tricks I find that are really useful is to be able to edit, instead of continuously chatting with it. So edit the historical chat would really help you to manage the memory, just FYI. But then this time it actually seems to be doing right. It's parsing the file and it's loading the file. So I just completely copied the whole thing and noticed that it also, for some reason, decided to do the user input for those variables. So I just kind of manually changed that, and then here we got all the images we want. The whole process probably took maybe 10 minutes or 20 minutes the most. A lot of it is just tweaking the prompts and then understanding what is not working and why. But this task, I would not even attempt to do it before LRM. And now it's really, really simple. It's just 10 minutes of chatting and trying. So from those two different, I guess, case studies, what I was really trying to say is, or what I was really thinking is, oh, seems to me a paradigm shift. We have the conventional machine learning, and now we have LLM. There are a lot of discussion. It's a lot of debates on if LLM really understands. And there is one analogy in an article that was published in 2017, trying to kind of describe what conventional machine learning is doing and what artificial intelligence is supposed to do. And it used the parrot to say it's kind of like the conventional machine learning and the crawl ability to describe the true artificial intelligence. And I want to also use that. I think it's a great analogy. So our conventional machine learning methods, it's still using a lot of data. It's looking at a lot of data and trying to figure out the pattern. However complex, it's trying to figure out the patterns. I can seem to be very smart because it can play even complex game like Go, but when it's used to do like a voice assistant before LLM age, right? It sometimes seems very smart. Please search up on the weather. It tells you what's the weather. But then sometimes it seems very dumb. Please recommend me a restaurant. I don't want Chinese restaurant. Not 100 of the time, but maybe 90% of the time, it's going to recommend you a Chinese restaurant, even though you specifically said do not recommend a Chinese restaurant. And that's a problem of the traditional machine learning way. It really doesn't understand it. It needs a lot of labeled, good quality labeled text to be able to actually find the thing you want. There's one thing, a test that to really test the the understanding ability of intelligence. It goes like, one of the examples goes like this. Joanne made sure to thank Susan for all the help she had, say, given. Who is she? And then another way you will ask, Joanne made sure to thank Susan for all the help she had received. Who is she? As human, we understand based on the given and the received, we really understand when you say who is she, it's either Joanne or Susan based on the context. But in the conventional machine learning age, it's really difficult. It's really difficult to achieve this kind of understanding unless you give it a lot of labeled data. And again, that's why the conventional machine learning can only deal with very specific tasks. Think about AlphaGo. Go has a lot of the possible moves in the game of Go is big. It's really big. It's so big that we think it's a really complex game, but it's still a limited game. But think about the possibility of our real world recommending a restaurant. It seems to be such a simple task, but the possibility of it is really, you can't iterate through all the possible suggestions, the way people ask, recommendations, the preference and all. So when it comes to a real intelligence, in the paper, it described it as a crawl ability. And what does it mean? So This is actually a video that was taken by a group of Japanese researcher. They are studying the animal, where they found in the urban areas, what the crow is doing, it will find nuts. And what it will do, it will drop it on the pedestrian crossing. And it will wait at the wire until a car comes and crushed the nut. So it's open. And it's not gonna go there directly. It's gonna wait until it sees the light turns green. And now it goes and it eats it. So what really happens here is there are three random things that happened that the crow was able to observe. One is a car can crash the nuts. Second is the car is controlled by the lights. And the third thing is I will die if a car crashes on me. And somehow it was able to connect dots and be able to kind of use the reasonings to see a logical behavior. It wasn't like the previous like looking at all the situations and figure out the best way. It really is understanding something that's deeper than just the surface data. And that's what LLM seems to be having. Of course, there are still a lot of debates on if this autoregressive algorithm is really something new, that it really can lead us to AGI. And my point is not that it can or cannot. I'm pretty sure there are a lot smarter people are thinking about this, but my point is, it seems that LLM is having some sort of probability that we can use it differently than how we use conventional machine learning. So this is how we've been using, the way we use machine learning have changed. In the beginning, we're just using parameters. Really, when there's new tasks, we collect new data, we label them really well, we kind of find the parameters, and then we either use inference or we try to like explain these parameters, and that's how we use it. But when LLM come, how we use it is really prompt engineering. So if you want to do some sort of sentiment analysis, we don't need to collect the data and label them and all that. We really literally just need to design the prompt in a way that LLM can understand and can give us the answer. And of course, with more complex tasks, there are agents, there are complex, workflow design and all that, so that it helps different LLMs to work together in the best way to accomplish things. So with that, what I'm really thinking is, okay, so it does sound like LLM is different from conventional machine learning. We know what conventional machine learning models can do almost. But what can LLM do if it's so different from conventional machine learning methods? And with that, the way I'm thinking about it is, let's go back to the beginning. So what is LLM? It's a lot more complex than what I'm saying here, but at its core, it's an algorithm that is trained on massive data, massive data. And the objective is simply to predict next token. That's what LLM really is. So from there, we can kind of think or infer what LLMs can do. Because it's trained on massive data, it's good at dealing with consensus in training data. And because it's trying to predict next token, when we're asking some less common facts, it's gonna hallucinate. Because the objective is not to give you the right answer. The objective is to predict the next token. If I haven't seen much of these tokens, then I'll give you something that's having a lower probability. So that's pretty much hallucination. And also for less common tasks, for example, if I ask LLM, how do I make $1 million? How do I be successful? And I actually did ask this, how do I continuously improve as a machine learning engineer? These are not tasks that are widely available. And it will say something that's correct. It will say many things, right? Like you should keep learning, you should keep reading, you should keep coding, something like that. But it's really not that useful to me. And from there, that's when I start thinking, okay, so on a day-to-day basis, what should I really use LLM to do? One of the things is this consensus-based task? I have a list of them. If I want to summarize an article on music theory, yes, it's done in many different ways, right? Like on the internet, there are so many even summarization tools to do this. If I want to research on music theory and chord progression, probably still okay, because even when I look at Wikipedia, it's a pretty good research on music theory. There's pretty good documentation and articles on chord progression. Now, when I want to learn about how to accompany in an orchestra with accordion, probably not. Why is that? Because accordion is not typically used in orchestra. And how you accompany with accordion really is unique, let's just say, to every musician. Even to different genres, even to like, what do you mean by accompany? It doesn't have a consensus at all. So probably not. So how I should really do it is search online, get those information and just summarize it with LLM. It's probably gonna come up with better connections with all these different articles I searched. And really, when I say, hey, compose a post of music for accordion, probably I should definitely not do that. The next thing I think is transformation tasks. I think a lot of the tasks actually fall under this category because at its core, LLM is a transformer. So I think it's really good at transformation kind of tasks. What do I mean by transformation tasks? Of course, translation between language, English to Korean, Korean to language, very easy to LLM. Transform between programming languages. So Python, JavaScript, very easy. Unless the programming language is already something that not a lot of people use, like Rust, then it's a little bit harder. Another thing is transform the natural language to programming language, and also actually vice versa, right? So one way is what we already saw, like what I did, it's the AI assisted programming. And if we translate programming language to natural language, it's literally just, explanation of a code base, which also is something we do pretty frequently. And there are also a lot of transform between different styles, right? So if I want to transform a repetitive code to a clean kind of code, it's like code refactor. There are specialized tools to do that. And there's also like transform from a lengthy article to a brief one summarization. Transform a draft to a polished article, email article. Those are just editing. So there's a lot of tasks that we should really rely on LLM to do every day. And the last one, of course, is those repetitive tasks. No brainer, right? So, but again, I think one of the things I notice is that a lot of the daily tasks, there is always a combination of repetitiveness and creativity. Like there's weekly business review that a lot of it is pouring the data, visualizing the data that are repetitive. We should and probably is already doing that with programming languages, but the analyzing part should always be us. So next question, really the million-dollar question is, okay, LLM can do so much, then what can I do? What should I do? What is something that's so unique about me that LLM cannot do that only I can do? I don't know. I don't have an answer. I cannot think of one answer to that question. But I was very inspired by this kind of statement that made in the article I found. It says, valuable opinions are contrarian and correct, which can never answer. And if you think about it, it's true. If, everybody knows how to be a millionaire, then everybody is a millionaire already. It's so valuable is because not a lot of people thinking that way, and it's the right way to think. So then millionaires becomes millionaires, right? Successful people become successful people. Of course, there are luck and everything, but I think this really inspired me to keep thinking on what should I do. I feel that on the contrarian side, I think Paul Graham also said this, that knowledge from afar, when you look at it, looks like a smooth surface. But when you look in, really dig in, look closely, there are gaps everywhere. And the way you make discovery is by filling all those gaps. So I feel in this age, it really is important to think deeply and challenge the norm. Why we do certain things the way we do it? Why can't we do it differently? And also, I think another thing is to be correct. I think it just needs us to keep building things. And like I have shown already, it's so easy with LLM to build things now. So easy. And just by building things and experimenting and keep failing even, that's how we learn and that's how we can be correct. I was really inspired by this random facts too, where we put a man on moon in 1969. But then we put whales on the luggage in 1972. So I feel to be able to build something that's useful, maybe we really don't need something that's so technically advanced. Maybe it's not that LLM hallucinates so much, or LLM is not doing this, and that is stopping us from building something. I think there's something more to it. I don't think we should blame the tool or the technology when it comes to building something that's useful. And I really want to end my talk with a quote I personally really liked from Steve Jobs. I feel like this is an age where our own uniqueness is extremely valuable. And I also feel like this is an age where our crazy ideas have a high chance of becoming something. Like I said, right? Downloading all the images from Instagram, something that I can not do, I'm pretty sure before, but I can do it within just like 10 minutes. So I feel really, as long as we're keep learning, keep experimenting, and keep building, this is how we can probably survive our. And with that, I open to questions.
Quick question about the two examples. So I noticed you use Claude.ai.
Yes.
So is there a reason for choosing that specific software over some other ones?
Yes, because GPT doesn't work.
Have you heard of like Devin as well?
I tried it. Actually, one of the things I was going to talk about is one of my side project is building a board game and solve it with reinforcement learning. Something that, again, if you asked me before how long it's going to take, 2 years, maybe 3 years. But with Devin, I was able to build it. A very simple one. It's called Sleeping Queens. It's actually a board game I bought for my 4-year-old daughter. It built that. So again, if you want to build a reinforcement learning algorithm, the first thing is you have to build the environment, which is pretty much the game. Like literally, you have to build the game as a code. So that building that game part with Devin took like 5 minutes, literally 5 minutes. It runs, it was fine. It's not the most beautiful code, meaning that you cannot really extend it with all those good like coding practice. It's not there, but it works. So I feel like, yeah, definitely there are tools out there that is just incredible.
There's so many new ones always coming out.
Yes, yes.
Thank you. So inspiring.
So what do you think about that edge case where we're talking about really uncommon data or stuff that like a technique that isn't written about a lot? You know, how do you think we kind of start digging into using the LLMs to help uncover that or open that up? It's one of the things I think about a fair amount of time. So I'm wondering what your thoughts are, since you very correctly pointed out the problem. So what are your thoughts on the solution?
Yeah, I don't have any. I don't have a solution, but I am also interested in that. And one of the field is called complex science. I'm pretty sure you probably know that already. And one of their main research topic is AI and science discovery. So it's literally just trying to answer the question you asked. How do we use LLM to do scientific discovery, which is rare and uncommon, and it's against my intuition that LLM can do that, but it's a like heavily researched area that I'm personally really interested in too.
In one of the slides where you introduce what is an LLM, so something like LLM, like for less common tasks, LLM will like generate something correct, but which is useless. So can you give us an example of?
Yeah, so for example, what I really meant is I search for how do I be successful? How do I be a good data scientist? How do I, stay current as a machine learning engineer? Those are things that there are articles out there, but it's not like, the answer is so unique to each individual. It's my understanding that LLM can say something that's right. So for example, it says you have to keep building a portfolio. You have to keep learning new skills. You have to keep taking more classes, which are all correct. I think none of them is wrong. But again, does it really help me? I don't think so. So that's what I mean. Yes.
I've been thinking about LLMs and I know, it's still a black box into like how they like determine what the next token is, but I was thinking how the difference between like an LLM writing, like creating a written piece, although it can do it really fast, it's really going like linearly, like whether in one direction, it's from beginning to end, but the way humans read is not actually that way. Like we kind of like skip around, like scientifically they've shown that like your eyes skip around and you're not exactly going from one word to the next, to the next, to the next. And I think similarly with writing, the act of writing, that as humans, like we may start with a thought, then like skip to another, then come back, I just wonder, like, I'm familiar with like video editing and I'm like, I feel like LLMs are like single track editing and whereas humans are like multi-tracks. But I feel like that might be too simple. What are your thoughts?
Human are single track as we are.
Like you can only go like humans aren't single track, but like an LLM can only like start, like if it was creating a video, it can only like start with like, the first image and then it would have to do a transition and then it would have to do the net, but whereas like an editor can like, and on the end, can be like, okay, in this track, I want you to apply like a transition, like across all of this. Like you can, I know you can do code and all that, but you were also saying how like you have to feed it the conversation back again because like it loses its train of thought. And I'm wondering if that's partly because it like, well, it's not really thinking, but like it can't go back to reference really what you were saying before, whereas a human brain can.
I think it might be related to how LLM just works very differently from how, okay, before I say that, like we don't know how a human brain works. And then we don't know how LLM works exactly, but we think how it works is we have those foundational models that are trained and then all the other things like the prompts and all that are just activating certain parts of the weights or certain parts of the memory of the model, and then that model just respond, right? Based on that activation. We don't know how human brain works. So we don't know if that's how the human works as well. I think what you're saying is, it seems that there are situations where humans are different, which of course that's true.
But when you're looking for like the edge case of like, what can humans do that LLMs can't? Like,
Yeah.
Perhaps it's because we're not linear, like LLMs. It may be different for a visual, but AI.
Yes. No, yeah, I think definitely there are a lot of other things. Again, I'm not saying what I summarized is like comprehensive of everything that we can do that LLM can't. But I think like what you're pointing out is that, yeah, there is another thing that we can do, which is the way we think from LLM is fundamentally different. And there are situations where we're able to think non-linearly, where LLM seems like we always have to give it a proper prompt, be it an image, be it a paragraph of an article, be it a question to an answer. But I think humans probably are not thinking like that. We can maybe, like, as I'm talking to you, thinking about a lot of other things may or may not be relevant to our conversation, but are something that is inspiring me to maybe something else. Which, yes, I agree.
Great. Yeah,
Yes.
do we have any questions online? We have a list of questions. Yeah, let's see if there's any new questions online and
I
then.
see there's a question in the back. I don't know if we have time for that.
So one of the slides which you put up, it was saying that you kind of wanna change your natural language to the one you want to see or you want to transform. So will the LLM help in smoothing out the learning curve? You wanna learn some other languages, kind of like if yes, will it smoothen it out or will it be more complex? Will it make confusion? Because as of now, when we use some GPTs, we can see that there are quite an error in the codes which are being transformed into, because they aren't able to figure out the language learning models which we are trying to like feed it. So what is your opinion on that?
I think your question is around translating one language to another. Well, what is the ability of LLM in doing that task? I think, again, like there are a lot of research on that, but my understanding is that the fundamental abilities are from the pre-trained model. So which means, so there are 3 stages, right, to train LLM. First is the foundational model, pre-trained model. Second stage is the supervised fine-tuning, and third stage is the reinforcement with human learning. A lot of the abilities to translate, again, a lot of opinions, my opinion, is that it's in the foundational model, which pretty much means what is in your training data, right? From GPT-3 to GPT-4, there's a huge improvement in Chinese language. From GPT-4 to maybe GPT 4.5, not much improvement from, again, I was testing Korean, still pretty bad. So from 3 to 4, 4 to 4.5, not that much improvement. So I'm more thinking it's really the training data that changed fundamentally. They included so much Chinese corpus in the fundamental model. From 4 to 4.5, probably a lot of the training happening in supervised fine-tuning and the reinforcement learning with human feedback. And those parts are more aligning with human intentions, not really giving it a fundamental better ability. But there are a lot of language-specific models. They're not training a fundamental different pre-trained model. They're still using, for example, GPT 3.4 or GPT 4, but then they did the fine-tuning part with the different corpus. And that also shows there are improvement in dealing with those languages. So I feel like if we're talking about those commercialized, like specifically GPT models, its ability to translation is from its own like training data change, and it happens in every major release. But there might be ways to improve specific language translation ability if we just use the existing model and then retrain it with the right language corpus. It's, again, my opinion. I don't know how many people believe me. There are so many different opinions too.
You with a question. So, yeah, we want to get to Brian, and then at the end, we may have some time for more questions at the end. So, yeah, Bailey, is there any, I see a new chapter as well. There's a new chat on the Zoom page. Great. Thank you so much.
Now, up next, we have Brian.
You're okay on yours? Got it. There we go. Yep. There we go. All right, so I'm Brian. You might be wondering, who this guy is who's showing up wearing shorts and sandals. I'm going to give a more traditional career talk, but I don't have a traditional career. I run a quant trading firm and have for many years been a partner or manager at quant trading firms. Been an investor in several quant trading firms, and I'm also on the faculty at the University of Illinois, where I teach algorithm trading in my not so copious free time. So I'll give a somewhat traditional career talk. I'll run through the slides pretty quickly, and hopefully we'll have time for the panel and questions, and we'll kind of go from there. Environment class strategies. Wrong one. Totally wrong presentation. Hold on a second. I'm going to stop this. Wrong presentation. Let me grab it. Luckily, I can grab the right presentation. There. Borrow.
Hi, including meeting controls.
Oh. Okay, there we go. All right. Sorry about that. Wrong presentation. I often get asked to do this specifically about quant finance, and this is a data science meeting, so I'll talk more about data science. So we've already heard a lot about kind of like, what should we think about? What should we focus on, right? Programming is required, it's not optional. Understanding some statistics is required, it's not optional. You don't have to start at either of those places. I started out in science, but I hated statistics. I started out as a computational physicist. Quantum physics is about statistics, but I never took a statistics class, not once. So I hated statistics because I couldn't figure out, well, how is this useful? Like, it doesn't look like the integrals I do all the time. It doesn't look like the probabilities I'm trying to figure out. So it just took me forever to figure out that had any relation at all to a business problem. For new jobs, domain knowledge should be required, but it's sometimes viewed as optional. So if you enter into this field where you don't have any domain knowledge, or you start out as a new data scientist and you get into a career field where you don't know anything about the domain, go figure it out. Go learn something about the domain. I've been in all sorts of industries where I've run into programmers and data scientists who feel like maybe they don't need to know anything about the business that they're in. And you're not going to ever get promoted that way. As Sunny very clearly pointed out, communication skills are required for advancement. You're going to have to be able to talk to people. You're going to have to be able to explain why. Why is this important? You have to talk about it. The reference here at the end is actually about explaining science. I'm a scientist. I can't help it. I put references even in my slides. So there are references at the end of my slides. And also knowing something about the business is going to be required for advancement. So you need to understand the business problems that you're solving. So this is kind of upfront. I spent 10 years as a consultant. So these types of circular graph things they're all over the place. There's a million of these about data science. I'm not putting this one up here so much for this graph, although it's actually pretty good about skills required for each section. But again, in the references, you can find the link to the website. This website is great for resources for especially junior data scientists. I give it to my young staff. to say, hey, here's things you can use to fill in your own careers. So I put it up here just so that you can kind of have a reference for later. So now let's talk about jobs, specifically about jobs, since this is supposed to be about careers. I think if you think about data science jobs, there's lots of different roles. And I've kind of ordered these in what is my opinion of the decreasing number of jobs. So starting with the most jobs and going to the smallest number of jobs, and increasing in specialized knowledge. So, starting with data analysts, there's thousands and thousands and thousands of data analyst jobs, go crunch the data. There's a smaller number of data visualization jobs. If you don't know Edward Tufte, find out about this guy. He's still teaching his seminars occasionally. He's a brilliant data visualizer. So he's got 4 books. This is his first one. I think it's his best one. But go find out about Edward Tufte. Data engineering jobs are about bolting it all together. Formal data scientist jobs, this fancy new data scientist title. And then of course now the new and shiny machine learning engineer. Which is data scientist by another name or a data engineer by another name, just using slightly different tools. Also, if you don't know XKCD, you should. It's funny. But he wrote this one many years ago. This is probably more than a decade old. Your machine learning system is pour the data into a big pile of linear algebra, collect the answers on the other side. If things are wrong, just stir the pile until it starts looking right. So I think it relatively describes what we kind of do when we start playing with some of these models. But now more seriously, what is the role of machine learning in data science? Well, most data science roles are going to be about data transformation and data visualization and data communication. Most of the business questions that you're going to need to answer probably don't need a machine learning model. So you can probably use much simpler statistics to answer most questions. And if you can use a simpler model, you probably should. Model complexity and model risk are a huge, huge problem, especially in my field of time series analysis and time series prediction. So machine learning is going to be a relatively small part of most data science roles or most questions that you get asked. So less than you might think, but still very important. We use machine learning models all the time. We don't use them to be one model to rule them all. There is no one model to rule them all, at least not in our opinion. We haven't found it yet. But we do find all sorts of places where we do end up using machine learning models. We use them for regression, fancy regressions, lassos, random forests, SGBoost. We use them for classification or clustering. Logistic regression, I love putting logistic regression on a machine learning slide. Logistic regression is considered a foundational machine learning model. However, logistic regression was invented in the 1800s and was done with a slide. But the whole point here is that the model itself is learning from the prior state of the data. So that's why it's considered a foundational machine learning model. Support vector machines, random forests show up again. Neural networks, of course, are used heavily for clustering as well as regression. And optimization models. We use all sorts of advanced optimization models in what we do because many of the problems that we face are not smooth. They're not smooth, they're not continuous, and so we end up using stochastic and machine learning type optimizers like particle swarms or DEOPTIM, or when you get into multi-objective problems, NGSA. So machine learning is very important to the job, but it's going to be very important for solving very small slices of the job. We don't try to find one model to rule everything. We try to find the right model to solve this one little tiny corner of what we're working on. And the references on this prior one are 2 books that are about introduction to statistical learning. The first one was written with R, and the second one does all the same things in Python. They're available for free online. If you don't know these books, you should find them. I'll show the references at the end. So what about AI? We've had 2 talks that talked a little bit about AI. It's a subset of the broader machine learning models. They're super trendy at the moment. They're obviously incredibly useful in kind of the chatbot world. They're incredibly useful in natural language processing because most of the data they've been trained on is natural language data. We do use them for code assistance. They work okay. They work really well for writing tests. If I take a body of code and I say, please write me a test suite that will give me full coverage of this function. Great, it'll do that. Save me a couple hours of work. I'm thrilled, right? If I ask it to instead, please give me a function that can apply a multi-objective optimizer using this set of features and spitting out this, this set of objectives, it's going to fail horribly because there's maybe 20 papers on this in the literature. So even if I tell it to read the 20 papers first, it's not going to understand them and it's not going to give me a good answer. So I know I'm still going to have to go do the hard work for the multi-objective optimizer, but I know that the AI code assistant can help me out with a lot of the stuff around the edges. And that's pretty useful. As we've already talked about, AI models are often not interpretable. They're not really technically black boxes. You can unpack a neural network model and understand what's going on deep inside of it. It's just hard. They do hallucinate. They especially hallucinate, as already pointed out, on uncommon facts when you're in these kind of much more specialized areas. And many business applications, not just in finance where I spend my time, but in lots of places, you're going to be working down in the corners, right? You're going to be working on something that hasn't been answered before. I mean, if it's like, hey, make me a sales forecast, given all this input sales data, I suspect it could probably do a pretty good job because there's lots of information out there about how to build sales forecasts. If, however, you're working on a really, really narrow area of some production problem, or you're working on a really narrow area of your data, and you're trying to unpack that, I think you're going to have a much harder time getting the LLM to help you. However, I'm going to expand that and give a slightly nicer answer. We're finding a lot of luck with RAG models, retrieval augmented generation models. This is really about taking an LLM like Claude or like Olama and fine tuning it on your data. So taking your corpus of data and then restricting the answer to the corpus of data that you gave it. So if you've got a giant pile of documents in a particular topic, if you've got a set of databases that have certain information, you can limit those hallucinations by building a RAG model that is talking about trying to anchor your decision making by looking only in that corpus of data for the answer. So AI models are proving to be pretty good at retrieving data and even to some extent analyzing it. But Gen AI models for now, in my field especially, are poor at predicting time series. Even the best models in time series prediction, like say Time GPT, are still falling way behind other more targeted models in terms of their accuracy. So we'll kind of see. So should you know about these things? Absolutely. Are these going to be your primary focus? Probably not. At least not at first, at least not early in your career. Maybe later on you become a specialist, okay, but early in your career, probably not. I will talk a little bit here about specifically careers in quant finance. The data analyst or data scientist or data engineer role, there's lots of them out there. Again, there are tons of these jobs online. So if you get a master's in data science and want to go become a data analyst or data scientist or data engineer in finance, there's lots of those jobs. However, you probably need to understand that those jobs are typically going to be on parsing and transforming data, market data, transactional data, so-called alternative data like satellite imagery or social media data. Again, here's a reference for what that alternative data is. Even though the data scientist role is usually taught, we teach it at Illinois, they teach it here, about predicting on data or modeling from data. The roles in finance that are called data analyst or data scientists tend to be relatively junior. And data scientists often have little industry knowledge. You might remember early on, I talked about the fact that you probably need to go get domain knowledge. So you can get the job, can get the first job without having domain knowledge, but really work hard, run fast to try to get that domain knowledge in whatever field you end up in, because that's how you're going to get advancement. Because otherwise you're going to have at least in finance, you're going to have relatively limited career progression at trading firms or big banks with a data scientist role. Compensation is usually salary and discretionary bonus. Your compensation is usually not tied directly to P&L. So that's the bad news. You don't make a ton more money if the firm makes a ton more money. The good news is you're also a lot less likely to get fired if your team doesn't make a lot of money. We'll kind of work up that chain a little bit. Now to the quant roles, the actual quantitative analyst roles. Middle and back office quants work on things like feature engineering. Here's a book by Kuhn and Johnson on feature engineering, post-trade analytics. This is Kissel, who used to be at New York University. Risk reporting, portfolio analysis. Bernard Pfaff is the head of risk at Invesco, which is, I think, the 5th largest investment firm in the world. He's one of my co-authors. We really like Bernard. Treasury management. Typically, these types of roles require both statistics and a finance background. Back to what I was saying about run really fast and learn as much as you can about the domain that you're working in. Because once you have that finance knowledge, you can start moving closer to the business. And compensation now is still salary and discretionary bonus, not tied directly to P&L, but you may be in a business group that gets a bigger bonus pool if they're making more money. So it starts to work in that space. Now the front office quants, all of my students in financial engineering at Illinois all want to run hedge funds when they grow up. Most of them won't. And I tell them that most of them don't want to because 80% of the people who take this job will leave finance entirely within 5 years. And most of them are not sipping margaritas on the beach. They didn't make so much money that they're going to sip margaritas on the beach. They burned out. They burned out or got washed out. But front office quants are primarily responsible for creating trading strategies. You're working on the indicators and features. You're working on the signal processes. You typically work closely with head traders or portfolio managers, or you hold those roles yourselves once you're senior enough. And compensation is directly tied to P&L. In fact, salaries tend to be very low, and most of the compensation tends to be upside. So if you want that, happy to talk to you about it afterwards. But I would caution you that, again, about 80% of the people who take this role will leave the industry and go into some other industry outside finance. And I'll have some final thoughts and then I'll take some questions. So skills every data scientist should have in any field. This isn't just finance. I think you should learn at least 2 interpreted languages. R, Python, Julia, Go, these are the big ones. I've written code in all of these. We routinely write code in both. I would say a giant chunk of our code base is written in Python. Almost all of our analytics is in R. R is way better at statistics than Python is. Way better. So even though I write Python every single day, when I need to do detailed statistical analysis, I'm going to reach for R. We've tried Julia. It didn't work too well for us. Go is pretty new. It's useful for certain things. I think you should know at least 1 compiled language. Java is the 2nd most popular programming language in the world after SQL. So I don't know that Java is necessarily the one you should know, but you should probably know at least 1, whether that's Rust, whether that's C++, whether that's Java, because there are certain things that you need to make go really fast, or you need to crunch a whole ton of numbers. And when you need to do that, you need to drop to a lower level language. R and Python aren't going to solve that problem for you. They just can't do it that fast. So you need to drop to a lower language someplace. You probably need to know some SQL for database skills. And I think you need to have want to have the ability to have all of those languages talk to each other. Don't be one model to rule them all, and don't be one language to rule them all. We try to reach for the right tool for the job. Today, it would be probably a bad career idea to not have some experience or exposure to cloud computing. Even if you're in an environment where you're not running in the cloud, you'll probably use things like Docker containers. So knowing about them and being able to use them is pretty important today. And some experience or exposure to machine learning and AI, even if that's not the main part of your job. And finally, to kind of close it out, some roles that you're going to have, but they might not tell you about earlier in your career. You're going to spend 90% of your time on all of these things and about 10% of your time on analysis or forecasting. You're going to spend your time cleaning data. You're going to spend time wiring data sources together. You're going to spend time moving data through the pipes, fixing broken data, and making data pretty. Turning a wrench or a screwdriver or swinging a hammer is far more common than painting a masterpiece. And I'm not trying to be denigrating at all. I held an electrician's license for almost 20 years, and I spent a few years building houses. So I certainly appreciate the trades, but I also understand that you're far more likely to use a simple tool and do a bunch of grunt work than you are to be working on the really awesome model. I spend way more of my time fixing broken data than I do spending it working on building some amazing new model for multivariate optimization or design of experiments or any of the other problems I wish I could spend all my time on. and simply can't. So before I take questions, I will say thank you all for your attention. This is the official part. These are all my ideas. The companies don't tell me what to say, and I don't ask them if I can say it or not. And this is not investment advice. And like I said, there are references at the end because I'm a scientist and I can't help myself. Thank you all for your attention, and I'd be happy to take questions.
Alright, so in-person questions first, and then we have the page.
Yeah.
Thank you, very insightful slides, knowledge. Wanted to ask you about what are your recommendations for, I would say, technical people with no finance knowledge to make that transformation? I heard like CFA and all these things. Is it required or?
I teach in the financial engineering program at Illinois. I took economics in high school. So it's absolutely possible. I started out as a physicist and computer scientist. The real key is you've got to kind of figure out what the kind of core set of knowledge is. You can look at the curriculum of any of these masters in finance type programs. You can pick out the things that look most important to you. But also I would say, think about building teams. My students are kind of a mix of engineering background and finance backgrounds, financial engineering masters. So we kind of get undergrads from both. And so what I tell my students is find somebody who knows the other half. So, because if you're going to go get a job, you're not going to be expected to be Superman or Superwoman, right? You're going to be expected to work in a team. And that means you're going to be expected to like bring your strengths to the job and find somebody else who brings their strengths to the job and work together to figure out the answers. So I don't think it's a giant problem to not have domain knowledge. I think it's a giant problem to not be willing to learn domain knowledge, right? Like I've been inside firms where the data team didn't want to listen to the business about what the data even meant. That's never going to work. It's going to fail every single time, right? Because you'll use the wrong data sources, you'll use the wrong structures, you'll do the wrong things to retrieve it. You'll turn something into panel data when you really need it to be vectorized. I mean, so there's all these things that require domain knowledge to even come up with the right technical solution. But I don't think you start, I didn't start with domain knowledge. I mean, I've been in finance full time for most of the last 25 years, but I started with zero domain knowledge. I started as a technologist. I was the CTO at a hedge fund and had to learn all the domain knowledge on the job. So I think it's absolutely possible. Does that answer your question?
Yes, I wanted to ask you about the CFA. So if you have like a data scientist with CFA, is this something impressive? Is something valuable in the market? Or?
It will help you get a job. Everything in the CFA you can learn online for free. There is nothing there, there's no magic in the CFA curriculum. But having the CFA will make it easier to get an entry-level job. Make sense?
I'm saying a lot of people don't stay with the career long term. What's the reason that they leave? And what do they go to?
So specifically front office finance jobs. So front office finance jobs are the jobs where you're actually managing the money. You're actually touching the strategies. They tend to be super high stress, super high hours. My normal day is still, my normal day is still over 12 hours. When I was running the quant trading desk at one of Chicago's trading firms, I was on the first train every single morning. I was at my desk at 6 a.m. It was rare for me to leave the office before 6 or 7 p.m. So a lot of people leave just because they don't want 12-hour days. Like, perfectly reasonable, I get it. Like, I totally understand it. But also it's just super high stress, right? You really are responsible for millions of dollars of either other people's money or your money. So a lot of people just don't want the stress. It also tends to be kind of abusive. I'll be completely honest. In a lot of front office finance jobs, yelling at people and swearing at people is still normal. Traders are not known for having particularly clear, clean language. So I think that there's a certain class of firms and a certain class of people where people succeed in front office finance jobs. I think middle and back office finance jobs tend to be much safer and much lower stress. Like, just like, but if you want to run the strategies, if you want to run the money, if you want to go be a hedge fund manager, well, also I've been a hedge fund manager, and most of being a hedge fund manager is raising money. So it's mostly being a salesperson, which I don't really like doing. So like you have to be okay with those roles, right? So one of the but really the largest reason that I see people wash out, I've hired a lot of new grads. We try to create a less stressful environment, although we still work really long days. But a lot of people leave just because of the stress. So that's in the front office. In the middle and back office roles, I think it's a very different career path. But especially in the front office, we find that about 80% of people who enter front office finance roles will leave finance and go into something else entirely.
The stress basically comes just because you see the impact right away, like bosses.
Some people really like gambling. I don't like gambling. Some people get we're scientists, we're not gamblers, but it's still really not a comfortable feeling when you see the number go down. It just does not feel good. Okay. So people don't like that. I don't like that. And I've been doing it for a long time. Yeah.
So in the last page, you mentioned you ready to do like some cleaning or to do some tailor for something. Can you give some like your example, like the top 3 criteria when you are giving like time, like financial time series data? What are your like how you use the acumen to tailor data better fit your financial?
So how do you use what to better fit the model?
Like your top 3 like criteria about your thought process to access those financial time series data.
So with financial time series, you've got a number of issues with the data. One is if it's high frequency data, there's lots of it. Potentially, like in some of the most liquid markets in the world, as many as 1 million messages a second. So you have to just simply be able to deal with literally billions and billions of rows of data. If you're dealing with vendor data, you've got all the regular issues of vendor data, missing data, bad data, that you're going to have to clean up, right? You're going to have to deal with that. You'll have to decide, are those NAs really NAs, or those NAs actually zeros? Can I remove those rows, or do I have to come up with something to put in those rows? And by the way, usually you can't interpolate. Like in many fields, in many machine learning models, they need a complete matrix. This is matrix algebra at the end of the day. They usually need a complete matrix. So in many fields that are not time series, or even some time series, but certainly not financial time series, you can interpolate data. In financial time series, there are only a few interpolations that are okay. Many other interpolations that you might do would bias your data. And if you have biased data, then your answers are wrong. Another problem you have with financial time series data is that it's what's called unbalanced data. So one of the reasons neural networks don't work particularly well for predicting on financial time series is because neural networks predict best when you have a balanced data set, when you have the same number of yeses and nos, or A's and B's and C's and D's, right? You have approximately the same. They're approximately called balanced data sets. So the problem with financial time series is that what I really care about are those really rare events. I care about the things that are least likely to happen often. And so it's very hard to train certain kinds of models to deal with that because I have these highly unbalanced data sets. So these are some of the types of problems that you deal with when you're dealing with financial data.
And for the quant finance, my question would be, what would be, you can describe your typical day of quant finance and as a startup fresher? What would be the KPIs for just the fresher starting in quant finance?
So the question was, can I describe kind of a typical day for a new person early in their career in quant finance? I'll give you 2 roles, one a front office role and one a middle or back office role. In a Miller back office role, the most likely thing to happen as a just young person is going to be that your team lead or your boss is going to give you a project and say, hey, we're working on this model, or we're working on this paper, or working on this idea. Here, go write some code to do this thing. Or here's a bunch of data, go use this set of models to analyze that data. And then you'll go off and work on it and come back in a week and talk to your boss and talk about it. And so you can think of it almost like a research seminar, kind of a master's or PhD level thing where you've got this project, you go off and you do the project, you struggle with it. You probably should ask your boss more questions than you actually do. And you don't go back to them often enough. And then when you finally come back to them, they're like, oh man, you didn't even understand what I asked you for. And then they tell you to do something else. So one thing I would say there, if you've got that kind of problem or that kind of project, is ask more questions. Don't ask your boss every question. Hey, I don't know how to write the next line of code. Go ask ChatGPT for that. And ChatGPT will be wrong a lot of the time, but you'll figure it out. Okay. But definitely go and ask your team lead, your boss, your other teammates. Hey, I'm not sure I understand this model. I'm not sure I understand what's going on. Help me understand, like, I'm looking at this and this data doesn't make any sense. Ask those types of questions, or struggle with it for a couple of days and then ask questions. Don't just like spin your wheels for a week. And then when you have your checkup with your boss about your project, like, oh, well, I don't know what's going on here, because that'll make your boss really angry, right? In front office jobs, back to the earlier question, why do people leave? When we were trading in futures, we had 47 hours off every week, because there are 47 hours every week in which there is no major futures market open anywhere. So for 47 hours, there's no trading, nothing can happen. You get to go home. But I was back in the office at 3 p.m. on Sunday, every single week, to turn everything on, because the most dangerous time every single week was when markets opened on Sunday night. So as a junior person with a front office role, one of the reasons people leave the field pretty quickly is you often end up working overnight. I've done it. Basically, everyone I know has done it. Has gotten the, oh, well, you've got to be in until midnight, or you've got to come in at midnight and be here until 10 a.m. So one of the things I would warn you, if you are thinking about wanting a front office role in quant finance, is you may very well end up, unless you work for the biggest firms in the world, they have follow the sun type teams. They have an Asia team, they have a Europe team, they have a US team. So unless you're working for one of the 20 biggest firms in the world that has a follow the sun model, you're going to end up working at really weird hours. Oh, you need to open the market at 7 p.m. Oh, you need to be in when Europe opens at 1 in the morning. So that's one of the challenges for even data roles in quant finance if you want to be in the front office. Make sense?
And that's all. Second question. Can you tell me the key performance indicators, the KPIs, measuring the success, the one who is starting as a project?
That might be a better question. You can talk to Brian after. I think we've got a bunch of online questions. Okay. Yeah, and I think we got a panel too, right? So,
Yeah,
we've got a panel coming up
yeah.
as well.
So
KPIs would be a great question for a panel.
And for that, we'll bring it over to Bailey. She has a list of the new questions and a list of questions we made on our preparation as well. So over to her.
Okay, I'll start with just the Q&A questions for now. The first one, easy question. Somebody is just wondering if we can put the slide on again with your contact information, Brian, if that's okay.
Sure. We just stopped
Thank you.
here. We can turn it back on.
Okay. And then the second question, speaking to continuing education, Kenneth asked, is there any service such as O'Reilly, Udemy, Pact that you recommend over others to further your technical skills?
Well, it's going to depend on the topic, right? So I think specifically, one of the things that you might need to think about is what topic is it? Because different places, MIT has a bunch of stuff online, UCLA has a bunch of stuff online, Udemy has stuff online, DataCamp has stuff online. It's really going to be what's the topic that you're trying to learn. I don't think one subscription is likely to solve all your problems, honestly. but I also kind of predate, I'm old, I kind of predate all of these things. So I've been kind of learning this stuff on the fly from papers and from just kind of figuring it out for a long time. So I'm not necessarily the best person to ask about that either. Great. Because you asked about the contact information. I'm easy to find, honestly, but I don't know. That's my contact information. So, okay. Any other questions, Bailey?
No, thank you. I think we'll wait for the panel. Thank you.
Thanks, everybody.
Okay, so we've got some pizza and we also have a panel where we can continue the Q&A and general discussion. So let's. Take a quick break here if you're hungry. 5 minutes, establishing the panel. Go ahead. Like I was an electrician for 20 years.
Nice to meet you. Hi. You're sneaking me in. Yes, actually. Okay. Yeah, and then you're everything. Yeah, and we're gonna convention together. Way back in the day, we're going up to.
Yeah, okay, so. Yeah, the CFA will help you find it.
We will see each other.
Yeah, I feel like the slides are so.
We should, since we're both so down.
Yeah.
Try to get a relatively traditional.
Yeah. Do you need a picture? Yeah, no problem. We found one.
I think they're gonna post this live. They're gonna put, well, the students are all being, so they're gonna post the recordings, right?
That's great. I do it since.